Hello everyone, let me introduce myself. My name is Alexander Kolesov, and today I would like to share with my paper. Okay, first of all, I'd like to introduce yourself with the task of this paper. Main task of this paper is transfer task. For example, what does it mean? I have digits 3 and my main goal from digits 3 to get digits 2. Okay, there are many ways in generative modeling to provide solution for this problem. For example, as you know, diffusion models that is able to solve this problem based on thermodynamics, like physics. But instead of thermodynamics, I decided to consider another type of physics, electrostatic models. Okay, in this case, I assign digits 3 like positive charges. Digits 2, I assign like negative charges. Okay, we remember the school, positive charges, negative charges. Oh, it's capacitor. Okay, we consider capacitor where the left plane is located, where in the left plane is located our positive charges, digits 3, here data set A. In the right plane, in the second plane, where is located our digits 2. For example, data set B. Okay, well, and our task is to learn the field between capacitor. Okay, we remember the school and understand that between plate of capacitor in the school there are field. Okay. But the main fact that namely this field provides transferring from one plate to another plate. Okay, well, it means if we learn this electrostatic field between these plates, finally we can go from the left plate to the right plate to generate from digits 3 to generate digits 2. It's my main goal. Okay, well. Finally, we choose the distance between plates of the capacitor. Locate digits 3 here, digits 2 here. Okay, well, what do we know from the school? For example, if we consider the arbitrary point between capacitor, we know that in this point, each data charge creates his field. For example, the field at this point is created by this data charge, this and this. Finally, we again remember the school, and we know that the total field equals the sum of each field from each data charge. Okay, well, finally it means for each point between capacitor, we can calculate the ground truth field thanks to our data set. Yes, we take arbitrary point, and the field in this point again is created by these points and these points. Okay, we have the field. Again, I remember that namely this field provides transferring from one plate to another plate. Okay, if we learn this field, finally we can move on from digit 3 to similar digits 2. But again, I remember it's my main task. But this approach has disadvantages. Which disadvantages? We again remember the school. And there are such problems like backward oriented lines. What does it mean? The field lines might go through the second plane, return, come back from another side. It's not comfortable for us. Problem. Line termination problem. Yeah, for example, we go through the second plane, where we should terminate, we don't know. We don't know, for example, because we cannot describe behavior of this line. Okay, and we have training volume selection. It's common problem for such methods. And what do? We change the physics. Instead of electrostatics, we go to the university from the school and remember the quark connection. Okay, we say, for example, my digits 3 is the quarks, my digits 2 is the anti-quarks. Then I locate to the left plate quarks, to the right plate anti-quarks. The main property of connection between quarks and anti-quarks is that their field lines are straight without backward oriented, without line termination problem. For example, we see here, before I had like this, with line termination problem, with backward oriented lines, but right now that new approach solves these problems. The field lines are straight and we have no backward oriented lines. Cool. We model this field with this formula that is explained in the paper. Okay, well, the algorithm is the following. We take the batch of digits 3, we take the batch of digits 2, we take arbitrary point between capacitor, and here in this point we calculate the field thanks to the formula like this, and again superpositional principle, and approximate this field. In sampling we make the same. We take the digits 3, and thanks to the learned field that approximates ground truth field, that again, namely this field provides the sampling from one distribution to another one, we go from one plate to another plate. And finally, we solve the problem. Instead of digits 3, we can consider noise. Instead of digits 2, we can consider dataset CIFAR10. For example, from noise we generate data from CIFAR10. From noise we generate images from CLEBA. As for results, our method works comparable with important and famous methods like diffusion models, GANs, PCGM, and so on and so forth. Comparable. But what advantages do we have? The main advantages, for example, in comparison with diffusion models, as we know, diffusion models has stochastic prods, left, right, go down, go up. Yes, stochastic prod with oscillation. But our field lines are straight. That fact means that this method is comfortable and convenient for distillation because we have straight lines. Okay, and for data to data we work the same properly. For example, we see that we have initial distribution digits 2 and we move on to digits 3 like this, yeah? And again we make, for example, the same from winter scenarios of landscapes to summer scenarios. Again, we work comparable with many methods, but better than that we compare in this paper. And again, we have advantages like practical, like straight field lines, and we have theoretical advantages like multi-sample estimation. Thanks for the listening. If you have any questions, I will be grateful to answer them.